Today we will discuss about order of reaction. The number of reacting molecules whose concentration alters as a result of chemical change is called order of reaction. Mathematically, it is also explained as the sum of all exponents to which the concentration in the rate equation are raised is called as order of reaction. जब भी हमारे पास कोई केमिकल रिएक्शन होता है तो उसमें नंबर ऑफ़ मॉलिक्यूल्स पार्टिसिपेट करते हैं, तो उनमें जो नंबर ऑफ़ मॉलिक्यूल्स पार्टिसिपेट ज़्यादा करते हैं और जो केमिकल चेंज जो होता है उनमें आ जाता है जिन मॉलिक्यूल्स में, इसका मतलब है वही हमारा रिएक्शन का ऑर्डर है. इक्वेशन इसकी शो करते हैं. ए इज़ एक्सपोनेंट, बी ए, दिस A and B are the reactants and C and D are the product. When the chemical reaction occur, A and B are the reactant, combine and change into the product value. What is the rate equation for this reaction? Rate of reaction is equal to K. K is the constant value. A in square brackets show the concentration and it is the exponent A. B square bracket and small b show the exponent value. Order of reaction is equal to A plus B. The exponent A or B in the rate equation give us the order of reaction with respect to the individual reactant. So, the reaction is the order of A with respect to A and B with respect to B. Note, the order of reaction in an experiment is experimentally determined quantity and cannot be calculated simply by looking the rate equation. Order of reaction provide us valuable information about the mechanism of a reaction. The order of reaction may be positive, negative, zero, or may also be in fraction. Now we will discuss the zero order reaction. What is zero order reaction? The reaction which is entirely independent of the concentration of reactant molecule. Mathematically, it is expressed as A. A is the product. Rate equation for this chemical reaction is equal to K is the constant value A. Exponent will be 0 because there is no concentration of the reactant involved. So R is equal to K. This sign shows that no change in the concentration. Here we discuss some examples of the chemical reaction. All the photochemical reaction usually zero order reaction. Second example is the hydrogen and chlorine gas when combined, no reaction will be occur in darkness. When we provide it sunlight, then it changes into hydrochloric acid. Third example is the ammonia 2NH3. When platinum added in it, it is act as a catalyst and it breaks down into nitrogen gas and hydrogen gas. What is the unit of K for zero order reaction? It shows that this constant value just for zero order, moles per decimeter cube per second. Next type of order of reaction is negative order of reaction. This type of reaction are very rare. For example, conversion of the O3 into O2. It is second order ozone. In case of ozone, when it convert into oxygen, it will become -1 order of reaction. It is negative order of reaction. First order of reaction, the reaction in which molar concentration of only one molecule alters as a result of chemical change, it is called as first order reaction. Mathematically, it is expressed as A is the reactant and after chemical reaction it changes into product. Rate is equal to K into A. This exponent value shows the order of reaction. Order of reaction is 1. Example, 2N2O5 changes into N2O4 and oxygen evolves. Rate equation for it, R is equal to K square bracket N2O5 and order will be 1. So order for this example is 1. Mechanism of this reaction is that N2O5 changes into N2O4 and oxygen atom. It is very slow step. Again N2O5 react with this oxygen it is fast reaction and change into N2O4 plus O2. What is the unit for this K constant for first order of the reaction? R is equal to K into A. K1 is equal to R over A. When we rearrange this equation, it will be occur. Unit for the R is mole per decimeter cube per second, and A is also the concentration of the reactant and its unit is mole per decimeter cube. This mole per decimeter cube cut with this mole per decimeter cube and per second is the unit of K1. Second order of reaction. The reaction in which molar concentration of two reactant molecules alters as a result of chemical change is called second order of reaction. Mathematically, it is expressed as A plus A change into product. Rate equation for this is equal to K. A and 2 will be the number of the molecules which are involved in this chemical reaction. So, order of reaction will be 2. Example for second order of reaction is hydrogen plus iodine. When these two reactants react and change into hydrogen iodide. Rate equation for it, rate equation is equal to K. Hydrogen, its molecule react with one molecule react with it, and iodine also one molecule. So order of reaction 1 plus 1 is equal to 2. Next example of second order of reaction is NO plus O3. It changes into NO2 plus O2. Rate equation for it K. NO1 O3 1. 1 plus 1 is equal to 2, so order of reaction will be 1. What is the unit for this order? K2 is equal to R rate over concentration of A reactant, and 2 reactants are involved, that's why we put here 2. Moles per decimeter cube per second, it is a unit of the rate, and mole per decimeter cube, again mole per decimeter cube, because here are 2 reactants, so that's why we write 2 times moles per decimeter cube. Moles per decimeter cube, mole minus 1, decimeter cube plus 3 per second, it will be unit of the second order of the reaction. Now we discuss the third order of reaction. In this case, 3 molecules involved in the chemical change. The reaction in which the molar concentration of 3 reactant molecules alter as a result of chemical change is called third order reaction. Mathematically, 3A means 3 reactants are involved in this reaction. It is changed into product. Rate equation for this K into A, 3. Order of reaction will also be 3. Example, FeCl3 plus 6Ki change into FeI2 plus 6KCl plus I2. Rate equation for this K is the constant value and FeCl3 1 molecule used plus Ki 2 molecules are used. Order of reaction 1 plus 2 is equal to 3. So reaction is third order. For this reaction is FeCl3 plus 2Ki. First step is very slow, and FeI2 plus 2KCl and Cl chloride ion will be formed. Again 2Ki plus 2 chloride ion react with potassium iodide, and it is the fast step. 2KCl plus I2 are formed. What is the unit of the K3? K3 is equal to rate over concentration of the 3 molecules. Moles per decimeter cube per second. Moles per decimeter cube, we put here this unit 3 times because 3 molecules are used in this case. Finally, the K3 has moles minus 2 decimeter cube plus 6 and per second. This is the unit of third order reaction. Pseudo first order. Hydrolysis of tertiary butyl bromide is the example of pseudo first order reaction. It is the tertiary butyl bromide. When it reacts with the water molecule, it changes into this one product, HBr, are formed. The rate equation determined experimentally for this reaction is R is equal to CH3 thrice CBr. The rate of reactions remain effectively independent of the concentration of water because water is used being a solvent so it is present in very large amount. Such type of the reaction is pseudo first order reaction. Next one is the fractional order reaction. Order may be in fraction. The order of reaction is usually positive integer or 0, but it can also be in fraction or can have a negative value. Example of the fractional order of reaction is, consider the formation of carbon tetrachloride from chloroform, CHCl3 plus Cl2 into CCl4 plus HCl. It is present. This reaction is occur in the sunlight. So rate equation for this chemical change is equal to K CHCl3. One molecule is used for that. We put here 1. Chlorine, half molecule is used. The sum of the exponent will be 1 plus half, 1.5. So order of reaction is 1.5.